Yo, what is going on, guys? My name is Jimmy. I want to welcome you guys to a video of BFS or breadth first traversal or breadth first search. I'm going to be showing you guys how to do this in C++. Basically, this is mainly sourced from Geeks for Geeks, but I did put my own twist on it because this method is a lot easier. There is no classes or anything like that, or namespaces. The only namespace you're going to be use is the standard namespace, and basically we're just traversing this this tree here. This is a very basic tree. There's no cycles, there's no cyclical structure to this tree, so it's just a very simple traversal. So let's get on to it. Alright, so we might as well start off with a empty template for you guys here. So you just want to have your regular include statements in this. You know, your IO stream. Obviously you want to have, you really only need a list, or basically your queue, and then you want to define your edge list with an X, and it's now passing a list of a pointer to adjacency pairs. So what that basically means is a pointer to an adjacent pair. You can think of a pointer as a blocks of memory, and then a list is already has already allocated blocks of memory. So you're basically making a 2D array, or you could think of it as a matrix in the situation. Yeah, that's basically how I think of it. And you can pretty much define X at X, and you want to push back. You want to push back your Y. So basically what this is doing is, in our situation here, 1 would be in our adjacency pair, and then you'd push back 2, so 1 is connected to 2, you'd have 1 is connected to 3, 1 is connected to 4, and so on, so on. Then you would have your BFS traversal, which would take in a starting node that you want to start the traversal from. In our case, we're going to start from 1. You'd want the amount of nodes, the total amount of nodes. You'd want, what else would you want? You'd want the adjacency pairs. Yeah, you want the adjacency pairs. The adjacency pairs, and that should be it. And we're gonna have to make a visited array here. Maybe because we don't want to be stuck in an infinite loop. We want to just mark the nodes that we visited, and then move on. We don't want to keep visiting them over and over again, because we'll just get stuck in an infinite loop. Here you can use a num set. We can use the visited, and we can until to false, and then have sass up. So then we can define our queue. We need a queue, because how a queue works is it's first in, last out. So basically you can think of a queue as, so you in queue on in the back, and you pop out the front. So you'd pop on the front. This is why BFS is, it doesn't go into the graph, like in the breadth first search would actually go into the graph and see each of these. Breadth first search would go here, 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 and then here, here. Wouldn't go anywhere, then here, here. For example, that's what breadth first search does because of the queue, because we pop the front node and then we unqueue onto the back. So if you had a, just to explain that better, if you had an array of 3, 4, 5, when you pop on, it would go to the back here, and then you pop off, that would take up the front there. So then we have a queue, and then we could, since we're starting at S, we can set our visited at S equal to true, obviously, because we've arrived at that node. So next thing we want to do is append S to the queue, because we want to check for adjacency pairs in S. So we can do queue dot pushback S, and then while the queue is not empty, so while there's something in the queue that we still have to check adjacency pairs for, like so, we can actually pop, or we can get the front of the queue. So this is basically the thing that we're going to be printing out. So we can do front, which is that, and then we can actually sequence out that would print out our node that we have currently arrived to. And then what we could do up here is make our list have an iterator. So in the namespace of list, there's defined a variable called iterator. We'll call it it. And then in here, we're gonna have to dequeue. So since we've visited this and we have s here, we can actually dequeue. So like so. And then we can, since we have s, we can s being equal to the one node that we're currently on, we can go through the adjacently list that we have defined up here. So it's because s would have adjacent leafs or nodes that we would go through. So we'd have it is equal to the adjacent of s dot begin. So the very first one, very first adjacent node to s would go as long as it does not equal adjacency at s, the final neighbor, like so. And then if the node is not visited, if it's not visited at the value type, or if the value of it is not visited, so if it's not visited, if we haven't seen that node yet, we'd want to mark it as visited. And then we would push it onto the queue. We'd push back it, and that's your basic traversal, guys. That's basically it. Return 0. Then in this particular graph, we have to define how many pairs there are, so 12. And then we do. Okay, and then we have to define our adjacency list. So we'd have list of ints pointer equals new list of ints of size n. And then we would have to add edges. So call add edge. So our add edge takes an x, y into the list. So you can see here, we can kind of do something like this. So you can see 1 is connected to 2, and then you can send the adjacency list. You can just copy this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1 there. And then we can call BFS starting at 1, and then we'll call put in, actually put in n, and we'll put in the adjacency list. Like so. So this should traverse. So we can go ahead and compile. Let me just write a quick for loop. You have traverse graph, kind of. I hope you guys enjoyed this video. It's kind of a shit video, not gonna lie. But yeah, it's pretty cool. Thanks for watching.